Hi, my name is Amy and thank you very much for watching. So tonight we are doing my 247th day of this stupid course. I have not actually been doing this for 247 days. I keep starting and stopping because I keep doing like Web3 hackathons and uh, a Web3 project on my own, so in the middle of everything. But since I got laid off on the 23rd of January, um, we're gonna start doing this more intensely. We're only gonna be doing this for like half 10, 20, 30 minutes today, not super long. But starting on Monday, we're gonna start doing this an hour and a half at a time because that is the same amount of time that the boot camp would have started in February that I don't think I'm going to be doing. Um, so hopefully by then we'll have this done. There's other resources for learning Solidity that I could look at if I feel like there's something I'm missing. But for now, I really just want to get through this whole course. Not going through the whole course today. We went through like 2 minutes yesterday. So we'll press. I already did the ad tax on this. So let's get to my 200 and something days of this.
Work with this VRF coordinator contract. Now, we're only going to set our VRF coordinator one time, right in our constructor. So what's the best thing that...
Have we set her? What are we doing? Draper, Austin, Asa. I don't need to know about that anymore. Okay. So why is this all red? Okay, so chain link contract source V8. Is there a problem with... Okay, well, let's do this, and then... Worst comes to worst, I can look at the source code on this and figure out where we went wrong. But we have version 8 interfaces, VRF coordinator, v2 interface.sol. We got the raffle. In the Alright, well, maybe this should not be private mutable here. Okay. So we have this that was commented out before. So VRF coordinator in here is bad. Oh, okay. So we've got VRF coordinator interface. Inside of parentheses, we have VRF coordinator B. So it's defined up the interface, this is the shape of VRF coordinator. And then this we're also defining, or we are passing in the address here and defining it inside the constructor. I'm pretty sure that's what this says anyway.
That we can do here. Private immutable, you gosh darn right. Let's do private immutable.
Okay, well, it complained at us last time, but it also wasn't in parentheses last time, so there's that.
VRF coordinator, and we'll change the name to I_VRF coordinator so that we know that VRF coordinator is in.
So we are changing this to I_ here and the here because it's immutable and immutable, and also it's telling me that we need a semicolon because of course it does.
Indeed an immutable variable. In order to request the random word, we need to give it a number of parameters. I'm going to go ahead and copy this line into our contract just
Really?
so that we can talk about exactly what's going on with it. And we don't need the S request ID. And instead of coordinator, we're going to do I.
So in the request, we can close this for now. Put this off to the side. So you have the request random winner here, which is empty for me. And then coordinator dot request random words. Key hash. Request confirmations. Callback gas limit. Num words. Some of these is going to have to be passed into this function eventually.
I_VRF.
Okay, so that makes sense. So you've defined the immutable coordinator, and instead of this as a constant, it's immutable. Why are you all of a sudden okay.
VRF coordinator. So we're going to call request random words on that VRF coordinator contract, and we need to pass it the key hash or the gas lane. I prefer calling it the gas lane. We go to the chain link docs, we go to contract addresses, and we scroll down, we can see different gas lanes and different configuration parameters for different networks. This key
really don't like my new mouse. I bought it because I'm tired of my other mouse playing dead, but I don't like the way that it's basically I hate change. I can show you, okay? Do I have my old mouse here? It seems like a thing I would do. Okay, so this is the one I was using before. And I got tiny little hands. So this is the mouse that just keeps going through batteries. And notice how like so it does sit like this, like this hand is the table, so it's ergonomic so I don't get carpal tunnel. And notice how my hand, like my thumb, it still doesn't reach these buttons because apparently only men with large hands need computer mice, but this is shallow, so my hand at least feels a little natural, and I can like, how do I normally even, I'd hold it like this, so it rests in the middle there. I can't reach these buttons, but it doesn't matter because it feels kind of nice in my hand. I'm used to it. This is my new one. Notice how deep this is, and my hand, like, I feel like I can barely, like, I can't even barely reach the scroll wheel. So I don't know, it feels like it is going into like the groove of this. It just feels, I think because of my small hands, I may have been like rotating it a little bit and the other one to make it feel more natural in my hand, but this one forces your hand to be a certain way. And I feel like the laser is not gliding on. I have like a leather side piece on the side here because I was trying to get into crafts, and it just feels like it's draggy. I've not tried to remove this leather thing to see how it works with like just the table, but it does feel worse to drag around. I just spent like 5 minutes complaining about my computer mouse. I hate change. Change is bad, y'all. But I do recommend, just as an aside, if you can afford it, and your ergonomic things, not, there's different trains of thought with ergonomics. So like this might be more your jam where it's thinner. This I don't know. This is the only kind I could find on Amazon right now. I do have an ergonomic keyboard here. It is, I am on a Mac, but this is a Microsoft ergonomic. And this is also one where this was the first type of ergonomic keyboard that I ever used. And it makes sense to me. It's raised in the middle, so my hands are positioned like this when I'm typing instead of like this. So keeping your wrists straight and not having to always have your hand. Basically, we spend a lot of time in front of our keyboards and using mice, and the more natural you are when you're doing all this, the less likely you are to get carpal tunnel or any of the wrist issues. I've been very lucky so far. The only time I had a wrist issue was when I was in spaces like 16 hours a day, and I hold my phone like this because I always have to yell at it because my reception is bad because I live on top of a metro station, and my wrist started hurting, so I bought and basically it's a stand You can rest the phone on the stand. There's a thing here for the cord to go for cord management for charging it. It folds flat. It's simple. I was going to, oh yeah, so keyboards. There's a lot of different trains of thought with this. There's kinds where basically it lays flat and your fingers like it's concave, so your fingers kind of go into it, and those seem really cool. They also have keyboards that are split down the middle, like they're just two different keyboards, so you can place them however is natural for yourself. I kind of feel like we went on a rant and a tangent here, but Amazon, and we can do like it's just that this type I have right now seems, well, it's kind of out of style, but it just seems like it makes sense to me that yeah, so like this is the kind that the keys are not curved out, they're just separate. Ergonomic. And so the thing with the mechanical keyboard is, well, they're loud for the ASMR appeal, but also they're kind of lighter on the touch, so you don't have to put as much pressure on each key as you're typing it. So the less resistance you have, the less trouble you'll have with it. So I was kind of talking about this, where this just seems weird. I would have to go to a store and try this out before I would get to it, or maybe someday people will enjoy me cursing at thing tutorials while I do them on YouTube, and I will get sponsored by someone like this, and I can try out their mechanical keyboards, their ergonomic keyboards. But until then, I've had good luck with my Microsoft brand ergonomic keyboard. I do, when it's reasonable, and these, well, this one's not that bad. Well, that one is expensive. If you look here, like, it's like $35 for a keyboard, but it's ergonomic, and it's probably much cheaper than going to the doctor because you have wrist pain. So just saying that I am having trouble adjusting to my new mouse. I went onto the Tain Link website to look at something that Pratchett Colin was talking about. I could at some point actually look at this. So they have two events here: request sent, request fulfilled. It makes sense for something that we should be doing. In their constructor, they are giving a subscription ID in the consumer base to firm owner. I don't know if you've been programming long enough, when they used to do foo and bar on everything, and there was a backlash on it where it's just like, nobody understands foo, nobody understands bar. And by nobody, I mean people that are coming up and don't care about computer science necessarily for programming and web. So I'm glad that we started doing like actual examples of things, because to me that makes it make the most sense. I don't even remember what I was supposed to be looking on in here, but yes, we're on the documentation website. I hate my computer mouse. What else do you need to know? I am going to check, because I usually go to a Is it time for me to leave? Are they having their Twitter space? If not, okay, we have gained another hour of your time. Congratulations. Maybe we'll actually get somewhere today. Um, yeah, we're I've been packing a lot. We're slowly getting there. Slowly and steady, we'll win the race. We're gonna get through everything, and everything's going to be amazing. So let me press play. We've only made it through a minute of this tutorial today. Remember when things were like really easy overviews and we were able to just go through everything, and I was like, yeah, we're totally gonna finish this in a reasonable amount of time. During the week, because I was laid off, I still have my job until June 30th, but no loyalty. We will be doing this for an hour or two during the workday, because I can, and I should, because this is going to help me get the next job I want, not just get me a job. But Web3 has a lot of contracting rules, and the way I'm trying to position my life is contracting and freelancing and doing my own stuff. And if I can get sponsorships while I'm doing it, that would be amazing. But let's just press play. I'm talking a lot. We don't need that.
Key hash is going to be the gas lane of the key hash, which...
Okay, so he was talking about the key hash, the gas lane hash value. Oh, right. Okay, so gas lane. He said that we can see information about somewhere in here. We have gas lane information.
Tells the Chainlink node the maximum price you're willing to pay for your gas and whey. If, for example, gas prices skyrocket and it's going to cost you a ton of money to get that random number, setting a ceiling will make it so that random number doesn't come back. For us to pick a gas lane, we're probably going to want to have this gas lane or this key hash stored somewhere. So let's go ahead and make that a parameter of our constructor as well.
This makes sense. So what they're doing here is get ETHUSD price. They're passing, they're actually getting the deconstructed value from the registry latest round. And then they're returning it. So then this here, I feel like there's a registry function here somewhere. No? Do not use this code in production, they say. This is a bad idea, they say. We're hard coding things so it makes sense, they say. This makes sense. Okay. Let's go back to still don't know what internal registry is. The feed registry, there's a feed registry interface in TeenLink, so I could go and look and see what they're talking about. I am not. I am just accepting it as fact.
And we'll save that as a state variable. So we'll do.
Okay. So I actually meant to just go to my thing over here. We're going back to the constructor. Constructor. Okay. So inside the constructor, we're adding a new thing, which is probably a uint 256, and it'll just be like gasoline. We'll see what he wants us to do.
Comma, bytes 32.
Oh, it'll be bytes 32. I'm gonna just, because I'm bad. In Solidity. So bytes is a data type that represents a fixed length byte array of 32 bytes. Okay, so what kind of, I feel like bytes anything, because it's a byte, it's zeros and ones. Yeah, okay. As long as it's only 32 inches, 32 bytes long. So that's interesting. It's probably because it's like an object that has to be stored as a byte. Yes?
Gasoline or key
Okay, well, I guessed the variable name correctly, at least.
hash, or whatever you want to call it. And then we'll make a new state variable. And we're only going to set this once, so we'll make this.
So bytes. Are you doing private? Private. Okay. And in the constructor, we would probably say something like equals. We'll see if I'm right or doing what he wants us to do.
Say private, immutable, I underscore gas lane. And then we'll say I gas lane equals gas lane. So now we can just swap this out for I underscore gas lane.
Okay, so we have the I gasoline. So now we just need to get all of the rest of these to be defined. We need a storage variable that is a subscription ID, which is how you read the S underscore.
Okay, what's next? We need a subscription ID. The subscription ID is going to be
the subscription ID that this contract uses for funding purposes. Did I create a subscription? Are they providing it in the course? How do we do this?
subscription that we need for funding our requests. There's actually a contract on chain which we can use to fund any subscription for any of these external data or external computation bits. And in this contract, there's a list of these subscriptions for.
So BRF. I feel like I have a subscription. Okay. Chain link verifiable randomness function. Do I create the subscription now or later?
People to make requests to. So we need the ID of the subscription that we're using to request our random numbers and pay the link Oracle gas. The subscription ID is probably also going to be something we're going to pass as a parameter to our lottery. So once again, let's scroll up to our constructor. Well,
this is an address. I think at a certain point, I know it's harder to read necessarily, but it got too big, Batman. There is a comma there. So address, something like that.
add a new parameter. And our subscription ID actually doesn't need to be a uint 256. It can actually
it's not a uint 256.
to be a little bit smaller with a uint 64.
So I guess it's really, oh my gosh, are you seeing this? Okay. We have the address, it has a subscription ID. Okay.
So we'll pass a uint 64 subscription ID. We'll make a uint
this is a uint 64 s. I'm gonna guess this is going to be private and immutable, but who knows. Then while we're doing all of the other things, equals, this is a lot of boilerplate, but it makes sense how he is doing this. I think it makes the most sense to define it I think if I was doing it on my own, I would be defining it here first, and then I would be defining it here and then here. but the way he's doing it makes sense as well, because at least now we know that, like, oh, this is not an address, this is a UINT 64. But like, so we know what the type is when we do subscription ID, and then we know what the contract is going to be, and so it works.
64. Since we're only going to set this once, we'll make this a private, immutable, I_subscription ID.
Oh, okay, so it is immutable and not storage. So, could have seen that company. Storage is generally more gas efficient than immutable. Storage variables are stored in the blockchain and persist even after the contract is complete execution. So gas upfront. Okay. Maybe it's because this could be dynamic. Interesting though, because you would think that the subscription ID is never going to change, so they could just kind of set it once and it'll be fine.
Down here, we'll say I_subscription ID equals subscription ID. All right, awesome. So now we can change this to our subscription ID.
Oh, right. So now we need to do request confirmations.
Okay, what's next? Request confirmations.
What are those? How many confirmations the Chainlink node should wait for before responding. The longer the node waits, the more secure the random value is. It must be greater than the minimum request block confirmations limit on the contract. So I think, oh, it's also a UINT 16. So we can come up here, UINT 16, call it request. The comma. UINT 16. Request. And then equals request confirmations with a semicolon, and then we can take that out and we will see how close I got to whatever he's trying to get us to do. I'm wondering, is there a default? Like, does this need to be defined? Like, if it's not defined, is it just set to like 7 or something like that?
Request confirmations is a UINT 16, which says how many confirmations the Chainlink node should wait before responding. So if you make a request and there's only one block confirmation, maybe you don't actually send it because you're afraid of some type of blockchain reorganization or something. We're not going to worry too much about this, and we're actually just going to make this a constant of 3. So we're not even going to have this be parameterizable. We're going to have this one be a constant. So we'll say a UINT 16 private constant.
So private constant, and it's just going to be a request confirmations, equals 3. And then JK, not this then. Not this. And then
request confirmations equals 3. And we're using the caps lock and
that's how you define constants, so that when you're just looking at the code, you could tell which variables are constants just by looking. Programming is good like that, where you can tell without having to actually read. Like, you can skim and you should be able to figure out what's going on with the code if you skim it, which is why I like frameworks like Vue, where it's like if you have to scroll, your component is too long and you need to make a new file.
Underscores for our constant variables here. And now we'll grab request confirmations and stick it in right here. What's next? Callback gas limit. Callback gas limit is going to be the
Limit how much gas to use for the callback request to your contracts. It must be less than the max gas limit on the coordinator contract. So basically what they're saying, if it's 20,000 way for 2 of them, which is 40,000, you set the limit to 100,000, so basically a little over double, just like a round number. Should be fine. Is this also going to be a constant?
limit for how much gas to use for the callback request to your contracts to fulfill random words. This sets a limit for how much computation our fulfill random words can be. This is a good way to protect ourselves from spending way too much gas if, for example, we accidentally code our contract in a way where fulfill random words is incredibly gas expensive. It'll block the random number from responding. We are going to make this parameterizable because we want to change it depending on how we code our fulfill random words. So in our constructor, let's add one more. We'll add uint.
Okay, and it's defined inside of the let's see, uint 256 private immutable. And you should make these at the top here. You should make these alphabetical order, so that when you're going through it, you can find what we're doing. But right now we're going through the list, so this makes sense. What is this? This is like, and then inside the constructor we can do uint 256 gas limit, and then we will change hold on a second. Just gonna change that into 3 places, and then we will call this there you go. And we are done with that.
32, since the size of this is a uint 32, callback gas limit, and we'll save this up top as a uint 32 private immutable I underscore call back gas limit. And we'll save this. I call back gas limit equals call back gas limit. And then we'll take this and we'll stick it here. All right, we got one more. Number of words. This is going to be how many random numbers that we want to get. We only want one. So we're going to go back up to the top. We're going to create a uint 32, and we'll make this also a private constant.
Okay. That's what I was going to say. I'll just say like uint was like 16 or something like that. Private constant. I think he said 32. I have a memory, I swear. Constant. What is this? This is the I could scrolling. Number of words equals 1 with semicolon. And then we can just do this and we're good. We're gonna stop here for right now because I just caught myself wishing I was not doing this anymore. So, and I also have a lot of things I need to do on my computer today that I cannot be streaming for. So, we will get off at probably within the next 5 minutes. So thank you very much if you're still here, if you watched the whole thing. Please let me know like what you're excited about with Solidity and what was difficult for you with this course. For me, it is literally just finding the time to do it when I'm not like tired and cranky and doing Web3's things. So there's that.
Constant num words equals 1, because we only want one random number. And then that'll be the last thing we need to add for our ivref coordinator request random words. Now this request random words function returns a request ID, a uint 256 request ID, a unique ID that defines who's requesting this and all this other information. If we want to save it, we can do uint 256 request ID ivref coordinator.
We do want to request this. So uint 256 request ID equals, and then we can do things with this like return request ID.
Coordinator request random words. Now for now, we are going to emit an event with this request ID, and we'll go over why we're going to do that a little bit later. Create a new event at the top, and we're not going to follow the naming convention here.
Okay. Event request ID event 32 to 56. Something like that? I don't know.
Because we're going to change the name of our functions a little bit. We're going to call this requested raffle winner.
Okay, so if we did this, it would be random winner requested. So like
and we're going to take a uint 256 indexed request ID. Down here, we're going to do emit requested raffle.
So instead of return, we're going to emit and put it in parentheses, the request ID.
Raffle winner request ID. And now we have a function that we can use to request a random winner using Chainlink VRF. Now, again, we're going to set this up so that the Chainlink keepers call this on an interval, but we'll do that in a little bit. For now, let's figure out what to do once we get that random number.
Okay, that's a tomorrow or a next time deal. So thank you so much for staying here with me, and I will talk to you later. I can figure out how to stop the stream. I